Hello, today we're going to solve this question here. So it's a complex familiar question. We're going to do, so what I'm going to do is just read a question. So we need using second derivative to find the maximum volume of this cone. So this is the cone, the pink color. So this is inscribed in a sphere. So the sphere with the radius is 7 centimeters. So that means we have a measurement, so 7, and the height is the cone is h, and the radius of the cone, the bottom, the base radius is r. So first question asks us to do is find out the volume against in relation to h, the height. So we need to find the function between v and h. So that's my question. So, okay, so how we do it? So let's have a look at some conditions we know. So we know because OV is equal to OP, which is the radius of the sphere, which is 7 centimeters. Sorry. All right, so now we will try to work out the volume. So first of all, we like to have a look at the volume formula first. In order to establish volume, so we know volume is 1/3 of pi r squared times by height. So this is the volume of the cone. So at the moment, we say we need a volume against h, but we need to get rid of the r squared. So we need to find out what is r squared in relation to, so we may call gh. So we need this relationship. So let's do that. So we're going to use this triangle here. So this is a right angle triangle. So we know in this right angle triangle is r squared is OP squared minus OC squared, which is a hypotenuse. So OP is 7. We already talked about before, 7 squared. Now OC, we know OC is OV, take away, sorry, no, CV, is that? So I'm gonna change to CVC. So this is which is VC, which is the height. So which is height minus the OV, which is OV is 7. So we got that. So then we simplify. So 7 squared minus h squared bracket minus 14h plus 7 squared. So expanding brackets. So it'll be 14h minus 7 squared. So cancel it out. So there'll be 14h minus h squared. So this is the r squared. So let's substitute into v formula. So our v will be 1/3 of pi r squared. So r squared is 14h minus h squared times by h. So expanding brackets. So there will be 14h squared minus h cubed. So that's it. This is the formula we just proved of relationship between volume and height. So now we're going to find the volume, the maximum volume when the h, so find h equal to what? Find r or h equal to what? So the v is max. So in order to do that, so we need to just using differentiate from a stationary point. So let's do first derivative. So it'll be 1/3 pi, then be 28 h minus 3 h squared. So that equal to 0. So we leads 2. So we put pi over 3 h, take it out. So it'll be 28 minus 3h equal to 0. So first we will get h1 equal to 0. So which is not applicable. Why? Because height cannot be 0. So therefore the second h2 is 28 divided by 3. So h2 is the one we want to use it. So in order to find out the, so we know the h, when h equal to 28 divided by 3, the volume could be maximum or minimum, we don't know. So, but how do we know? So how do we test it whether it's a maximum or minimum? So we need to do a second derivative. So let's do v double dash, which is differentiate the 1/3 of pi and 28, then minus 6h. So now we will lead to, let's substitute v h equal to 28 divided by 3 into the second derivative. So we will find out 28 minus 6 times by 28 divided by 3. All right, let's work out. So this is the cancel it out. So the answer you can see here will be negative 28 1/3 pi. So which is negative. So when second derivative is negative, so our graph will be concave down. So there will be max. So we prove this volume will be maximum. Will be maximum volume. So when h equal to that. So then we will see, okay, so let's find out the R. So what's R? So we know R square is relation between R and H is R square equal to 14H minus H cubed. So that will give us so let's have a look. So that's give us the R, substitute into, so therefore we will substitute the H into the equation. So what is H? H is 28 divided by 3 minus h to the power 3, which is 28 divided by 3 to the power 3. All right, so this gives us the R squared. So then we will, R will be square root of that. So the square root of this. So the end up R is 14 square root 2. And swap out. So simplify this. So don't forget here, there will be another there. So we simplify to this will be 3 underneath. So this is the R. So now we're going to find out the maximum volume. So we substitute into the volume formula. We already prove. So the maximum volume will be achieved when H equal to 28 divided by 3 square minus, so this is square bracket, and 28 divided by 3 cube. All right, so work it out. Actually, we can use, yeah. So our maximum volume will be equal to, just check the solutions. Actually, we might use the other formula, because the other formula was 1/3 of pi r squared. R squared is 14 square root 2 divided by 3 squared and times by h. So just work out the answers. So that's end up, we will find the solution. So this is how you found the maximum area. So this using second derivative to find the to test whether it's a maximum or minimum, and also using the relationship between R and H to solve this volume against H. Thank you for watching, and see you next time.